Hi. So, you know who I am. Cutting to the chase. I have a nice whiteboard I'm so glad that I found. So we're going to talk today about solving one-step equations. Okay? So when we solve one-step equations, some words that I would throw on an anchor chart would be zero pair. Zero pair is when we have a negative and a positive. So if I have a -1 and a +1 together, they make zero. Because if you are in the hole, -1 in the cafeteria, and you pay $1, your balance is now zero. You brought your balance to zero. I have a -5 and a +5, it's going to equal zero. And I'm in the floor because this board is on the floor, so just bear with me. An equation, the opposite, I'm not even going to say opposite. An equation has an equal sign like these. We also may be able to look at inequalities, which we briefly talked about before pandemonium took place. So an equation has an equal sign. Inequalities have greater than or less than. They might even have greater than or equal to or less than and equal to. So we have inequalities, we have equations, and we have zero pairs. Those are some vocabulary words for you to know. When we solve one-step equations, we are trying to get x by itself. And sometimes it's y, sometimes it's n, sometimes it's b. It just depends on what they decide to make it. So we've got x minus 2 equals 10. So I have to think about a zero pair. I need for this to equal 0. But I have to remember, like a fraction, whatever I do on this side of the equation, I have to do over here. So I need to think, what's the opposite of minus? What you think? What's the opposite of minus? I think I heard somebody say plus. Yeah, so we're going to do plus 2. So that leaves us with 0. If I do plus 2 here, I have to do plus 2 here. So I would do, that would be 12. So now I can rewrite this as x equals 12. And that is my answer. Now, the beauty of this is we can check it. So I can plug 12 into x. 12 minus 2, does it equal 10? It does. It checks out. 12 minus 2 is 10. All right, so that worked out nicely. All right, so now let's take a look at x plus 3. So I have to get x by itself. Again, I have to think, what is the opposite of plus? I just said it. I do that a lot. The opposite of plus is minus. So I'm going to say minus 3. That's going to be 0. And then whatever I do on this side, I have to do here. That's going to give me 2. So I'm going to rewrite with what I have left, x equals 2. Then I can check it. 2 plus 3. Does that equal 5? It does. It checks out. Is it all coming back to you now? I hope so. All right, so now let's look at 5 plus y equals 12. Now remember, this doesn't have a sign in front of it. 5 doesn't. But because there's not a negative, we know that 5 is positive. So a positive 5, how can I get this to 0 so that I can put 5 over here? I've got to do plus 5 or minus 5? You got it, minus 5. It's going to give us 0. Whatever I do over here, I have to do on this side of the equals. So that's going to be minus 5. And then 12 minus 5. 7, 8, 9, 10, 11, 12. Yes. So now I'm left with y equals 7 as my answer. I'm going to plug it in to check and make sure, I'm going to write it right here so you can see it since my whiteboard is kind of low here. So 5 plus 7. Does 5 plus 7 equal 12? Yes, it does. Beautiful. All right, so now I'm going to look here. I've got 10 plus y equals 45. Now, many of you are already like, well, duh, I know what that is. I know what's missing. Great. That's awesome. So we know that this is really a positive 10. So to undo that, to make this 0 on this side, I'm going to say minus 10, which leaves me with 0. And then I'm going to do minus 10 here on the other side of the equal sign. And I'm left with 35. Y equals 35. And that's going to be the answer. I can check that now. And I'm going to check it right here. So 10 plus 35 is indeed 45. Isn't that nice? Okay, so that's adding and subtracting. I don't know how well the screen is going to erase. Not too shabby. Green likes to leave a remnant. All right, so that's adding and subtracting. And remember, we're just doing one step right now. We'll probably review 2-step a little later on. And I would use another color, but it's not doing very well. It's like on its last leg. All right, so another, what else you might see? You might see 3m equals 15. And you might see x divided by 2 equals 6. All right, so what are these two numbers? What's the operation happening between 3 and m? If you said multiply, you are right. Yes, so this is really 3 times m equals 15. So how can I undo multiplication? How can I undo that? Just leave it. I can divide. You are correct. So I'm going to divide by 3. And that's going to give me, that's going to let those become 1. Because remember, 3 divided by 3 is 1. So that leaves me with 1m. And then I'm going to need to divide by 3 over here because we still have to do that same pattern. So m is going to equal 5. And again, I can just plug that right in. 3 times 5 equals 15. Yes. All right, so now we have x divided by 2. You probably already know this. You're like, oh, I know exactly what x is. Great, this is how we have to solve it. So I've divided, so I need to undo the division. The only way to undo division is to what? Multiply. So I'm going to multiply by 2. When I multiply by 2, that's going to make these be 1. So it's like x divided by 1, which is x. And whatever I do over here, I have to do here. Oops, and I'm not dividing. I'm timesing. And 6 times 2, which you can't see, is 12. So x equals 12. So then I can plug in 12 for x. I can say, okay, 12 divided by 2, yes, that's 6. It checks out. So go ahead and work the practice problems that I've put into Canvas for you to work on to get some practice with one-step equations. Have a good day.